Good morning, dear students. The subject computer organization. The last two sessions we have discussed about the basic organization and the historical perspective, that is different generations of the computers. Now today's class we are going to discuss about the third topic of your unit 1 first part, that is bus structure. So actually, what do you mean by a bus and what is its significance in the computer organization? So as we have already discussed in the first session itself, there are different types of components are there in a computer basic structure. So basically they are classified into hardware components and software components. I told you by using these software components like your data, the instructions which you have typed in the form of a program by using different types of languages like machine language, assembly language and high level language. The hardware components will react and communicate with each other. Here, see, if two persons wants to communicate with each other, definitely we will use a media. So for example, if both the persons are sitting together side by side, they can directly talk to each other. If these two persons are there in two different places, then nowadays, as you know, we will be using telephone system to communicate with each other. Fine. So we need not go more elaborately how two persons will communicate with each other. Now that is not our basic topic here. In the same way, different components that are existing in a computer, how they will communicate with each other. As you know, input devices, output devices, arithmetic logic unit, control unit, memory, again storage unit, means primary memory or secondary memory. Like that, there are different components are there, various components. Put together, they are connected. We told you how they are connected. In the first class, I told you all these components are connected by using certain group of wires. I told you those group of wires. In the first class itself, I have used the terminology called as bus, and I told you that we will discuss about the bus structure in the third session of this subject. Now, this is a time to discuss about the bus. Now, to communicate all these components with each other, you might have understood by this time, we use a basic device called as a bus. Now, the CPU sends various data values and instructions and also information to all the devices and components inside the computer we discussed. Why I am stressing on this point is CPU sends. Why CPU sends? I told you the CPU, central processing unit, contains two components in it. One is arithmetic logical unit and the control unit. And when we discussed about the working nature of the control unit, in a single statement I can tell you now, control unit is the major device in the CPU that controls all the components of the computer. So when we need to send data, to where we need to send data, when some storage device will receive data, or when some output device will receive the data, and how to pass the instructions and the information to various devices and components that are inside the computer will be controlled by the control unit only, which is a part of CPU. So that's why the CPU sends various data values, instructions and information to all the devices and components inside the computer. Fine. Now, for passing, for sending all these devices, all these instructions to various devices. The component we use here is the bus. Now what is a bus? A bus is defined as a network or a group of wires or an electronic pathway. We told you the main question is how the CPU communicates with all these devices. The answer is common bus. Just now we have gone through it. Now, what is a bus? So, bus is defined as a network or group of wires. Bus is defined as a network or group of wires, or it is also called as an electronic pathway. I told you in the first session, the length of a bus determines the efficiency of a computer. How and why? See, if a bus contains only 4 wires together grouped, only 4 bits, 4 data bits, bits here means either 0 or 1, can be transmitted together. If the bus length is 8 bits, so 8 zeros or 8 ones are a combination of zeros and ones, 8 can be transmitted together. So keep on, if you are going to increase the length of the bus, those many bits can be transferred together to all the devices. So the length of a bus is major role in increasing the efficiency of a computer. Now how the bus is going to function? Of course, we told you it's an electronic device or electronic pathway grouped together with the number of wires and connected to all the components. So it is a communication pathway connecting 2 or more wires, and it is used to share the transmission media. So to this bus, multiple devices are connected. Multiple devices, like there may be input devices, output devices, primary storage, secondary storage, external devices. External means which are not with the computer or CPU, like maybe pen drive, okay, or your printer, or whatever is a platter, scatter, etc. Where different external devices also connected using this bus, and a signal transmitted by any one of these devices with the help of the bus only. Now, a bus, 2 devices transmit during the same time period. So, for example, if CPU is passing signal to an input device, for example, and parallelly we are also working with the printer, the papers are going on in the printer, print is coming out. It means number of devices together can communicate with each other. So this signal sometimes may be overlapped. So if CPU may be passing signals to the input, and it is maybe receiving the signals from one unit, and maybe it is passing signals to the printer or copying to pen drive, or maybe mic, speaker, or whatever it is. When different components are connected, so if the CPU wants to send the device signals to all these devices, the signals sometimes may overlap and maybe garbled, means mix up, mesh up. So thus only one device at a time can successfully transmit. But nowadays is it what happening? No. Multiple devices are working together. For that, different types of bus structures are generated. Okay. Now, so this is the when you discuss about the structure of the bus or various issues to consider for designing a bus, how various signals can be transformed to different components of a computer with the CPU, and vice versa, we will discuss. So typically a bus contains multiple communication pathways or lines. Each line is capable of transmitting signals representing by what? We have discussed as the computer is an electronic device. So signals that are represented in the computer are only in the form of binaries, that is 1 and 0. So any data that is transforming in these components, between these components, is in the form of zeros and ones only. So several lines of a bus can be used to transmit binary digits simultaneously, means parallelly. So if 8 lines are there, 8 ones or 8 zeros or 8 common, 16, 32, 64. See, I am talking here about 4, 8, 16, 32, 64, 128 like that. It means that definitely the bus length should be in terms of powers of 2. In terms of powers of 2. Why powers of 2? There are only 2 binary values 0 and 1. So you can send 2 bits 2 power 0, 2 power 1, like 2 power 2, 2 power 2 4, 2 power 3 8, 2 power 4 16, 2 power 5 32 like that. So always you can observe that the length of a bus is nothing but in the form of powers of 2's. So powers of 2's. It's not like 10 lines, it's not like 14 lines, it's not like 20 lines like that. Okay, remember this is very important in designing of a general bus. So an 8-bit unit of data can be transmitted over 8-bit lines. So 16-bit unit of data can be transferred over 16-bit lines. So like this we will transfer the data between various buses. Okay, now how a bus definition, just now we have discussed. A bus is defined as a network. It is a communication pathway connecting 2 or more bytes, and it is used to share transmission media. Multiple devices are connected to the bus and a single transmitted by any one device. Now let us have the bus structure just now discussed. Basically, what are the various devices that are connected with bus and what are the speed of those devices. Now nothing but simple, the components of a computer are connected with bus. We can say within one line the components of a computer are connected with bus. Now the components of the computers are categorized or classified into many devices. Say for example, input devices and output devices. So as it is shown in the slide, keyboard and printer are the best examples of your input and output devices. They are called as electromechanical devices. They are called as electromechanical devices. See, in general, when we compare with the central processing unit speed, these IO devices speed is deadly slow. So if a CPU is transmitting 16 bits of data together, because it is a parallel sending, these devices like electromechanical devices like keyboard and printer will take only one signal at a time. These are the serial devices, serial port devices, whereas the CPU is a parallel port. So 16-bit data transferred to the printer or to the from the keyboard to the CPU or whatever it is to the monitor, but only one by one will be transmitted. But how, when 16 bits comes together, when it is receiving only one bit at a time, how this timing will be matching? How this timing will be matching? That is one of the important design factor of the computer. How it is going to be overcome, we will discuss in the later. And next type of devices that are connected with the bus are magnetic or optical discs. They are a little bit high when compared with the keyboard and printer. And the third one is memory and processing units. Its speed is very high. As we told you, this memory and the processing units are all parallel devices. So they can receive the data, they can send the data, group it together parallelly. That's why they are very high in speed. So these are the different types of devices that are connected. And of course, finally, there is one more basic device that is connected with the bus is buffer register. So what is this buffer register? Why it is used? Just now we have discussed when a low speed device is connected with the high speed device. When a low speed device is connected with the high speed device, there is a problem occurs while transmitting the data that is called as synchronous or asynchronous. So to avoid this problem, we use these buffer registers. So if a parallel device is transmitting 16 bits of data. Perhaps a printer is receiving only one bit at a time. So during that time, this group of buffer register will store the data, 16-bit data in 16 buffer registers, and one by one will be transmitted to the printer. So that this buffer register will act as interface between high speed and the low speed devices. This buffer register will act as the interface between the high speed and the low speed devices to transfer the data, to avoid overlapping, to avoid miscommunication. So these are the four types of devices that are connected by using a bus. And now next one, what are the types of bus structure? So there are basically two types of bus structures are there. One is single bus structure and the second one is a multiple bus structure. Now let us discuss about each bus structure in detail. Let us come to the first one, single bus structure. So in computer architecture or organization, we know a bus is a subsystem. It's not fully a computer, yes, because there are some other devices also, input devices, output devices, storage units. Along with those, a bus is a part of it. So in computer architecture, a bus is a subsystem that transfers the data between components inside a computer or between two computers also. Sometimes, definitely, if a number of computers are connected with the LAN, there may be a need arises to transmit the data between one computer to another computer. So in the LAN communication system, we may be using terms called as servers and clients, etc. Clients are all together working under one umbrella called as a server. So with the help of the server signals, two computers, individual computers that are connected under LAN also may communicate with each other. Even for that also, we use bus only. So in the early days, computer buses were literally parallel electrical wires with multiple connections. But modern days, nowadays, to match the time speed between the serial ports and the parallel devices, parallel ports, in the modern computer buses are using both parallel and serial connections. You might have seen them various, even your smartphones are also connected with some group of wires put together on the single circle. So inside, if you see, there are a number of small wires are there, which is called as a bus only to transfer the data. So because the bus can be used only one transfer at a time, only two units can actively use the bus at any given time. So, but if only two units are acting actively, how can we perform number of tasks in faster speed? So for that purpose, there are some other techniques which we will continue. So this single bus structure, by using this single bus structure, we use to communicate between only two devices at a time. And basically, the advantage of single bus structure is, you can see here, a single bus structure diagram is there. One common bus is given that is connected with the input, output, memory and processor. If you can see the arrow marks that are connected between those devices to the bus are different. To the input, only one-way path, that is down, means the CPU or the processor will receive the data from the input device. It will never give the data to the input, yes or no. So that's why it is in low direction. And if you see output device, from the processors, from the CPU, data will be transferred to output, whereas from input, data received, to output, data transferred. That's why the direction of that bus line is in the upper way. When you see the remaining two, memory and processor, both, memory will receive the data and also memory will gives the data. That's why the bus structure is bidirectional. So in the same way, processor will receive data from inputs and will receive data from memory. Sometimes processor will gives the data to output, and if required to store, also stores the data in the memory. That's why that is also connected in the bidirectional mode. So there are basically two types of two directional buses here we have discussed in the single bus structure. One is unidirectional and the second one is bidirectional. Unidirectional and bidirectional. That if you see the diagram itself, it is going to tell you that the designing of this bus structure is takes low cost. That is, the amount you need to require is very low, and it is very flexible for attaching also. There is no confusion in the group of facts. Simply, it is very simple to connect the various devices. These are all the two basic advantages. But I told you, disadvantage means if n number of devices wants to communicate with each other, it is not possible with the single bus structure. So you can see the bus diagram: input, output, memory, processor. So in the input, for the output, as I told you, unidirectional connections are given. For the memory and processor, bidirectionals are given. So this is a simple diagrammatic representation of a single bus structure, how a single bus is going to work out. Now second one, multiple bus structure. So multiple bus structure, as I told you, it is definitely having an advantage over single bus structure. That is, its performance is better. Means number of components will be communicating with each other with the help of multiple bus structures. So two or more transfers. As I told, in the single bus structure, only one transfer at a time. Whereas in the multiple bus structures, two or more transfers can be carried out at the same time. That's why definitely its performance will be high only. But definitely when it is transferring the data between n number of components, we need more number of connection criteria, etc., etc. That's why it is its cost will be little high. So the major disadvantage when compared with the single bus is increased cost. So you can see here how a typical bus structures are classified. As we said, single bus structure is only one, and here when you come to the multiple bus structure, in the diagram you can see basically three types of buses are connected together. The topmost one is local bus, second one is system bus, the bottom bus is expansion bus. Now what each bus is going to do? So basically this multiple bus structure is of three types. One is local bus, system bus and expansion bus. So what the local bus is going to do? You can see in the diagram, the local bus is communicating data between the processor and the cache and local I/O controllers. So what is this cache? You might have learned about the cache memory. So it is used to store the data temporarily for the easy access. Means if the data is there in the storage devices, if the processor wants to perform the activities too fast, every time getting the data from the memory and storing the data in the memory becomes difficult. That's why whatever the data or the information that may be frequently used for more number of times is kept in the cache memory, and every time the processor will receive and send the data that is being used for more number of times with the help of the cache memory. So to transfer the data between this cache memory and the processor, we use the local bus by using some local I/O controllers. Okay, now you see the middle one, the system bus. Okay, so system bus is connected with cache memory and also connected with main memory, and also you can see expansion bus interface. So expansion bus interface. So here a system bus connects with all processor, memory, I/O devices. Like, so you can define a system bus as a bus that connects major computer components. A bus that connects major computer components like processor, memory, input output device are called as a system bus. You can see in the diagram of the system bus. Okay, it is connected with the main memory, also sends the data to the cache memory. Through cache memory, it also sends the data to the processor and also to various input output devices. Okay, so see, what are the types of buses again in the system bus? There are basically three types of buses are there in the system bus. One is data bus, second one is address bus, third one is control bus. So of course, apart from this data address and control bus, in addition, there may be power distribution lines that supply power to the attached modules. So for all these different components, if they want to work out, definitely because it is an electronic circuitry, electrical signals are required, so some cabling is also need, power distribution. For power distribution lines we call as those, with the help of those power distribution lines, first of all we need to bring all these devices into active. Okay, a system bus consists typically these three types. One is data bus, address bus, control bus. Now let us discuss about each and every bus in detail. See, you can see in the system bus model, there are horizontal lines, three lines are there. One is data bus, second one is address bus, and third one is control bus. If you see the first one, data bus is connected with all three devices in bidirectional. CPU, which contains arithmetic logic unit, control unit, and also some registers. And memory, it may be primary memory or secondary memory. It is nothing but a storage device. And peripherals, input devices and output devices. So data bus is connected with all these three devices in bidirectional. So it sends the data to all these devices. Also it receives the data. So to communicate with different lines. Whereas if you see the address bus is connected with the CPU, memory and input only in unidirectional, means it receives the address from the CPU. Address means memory location. So I told you in the first class itself, when we discussed about the storage devices, memory is nothing but a group of locations that are organized in the stack based. Each location will be given an address by using a binary components. In the same way, input device and output device also will have certain number, sequence number called as identification addresses. So first, the address bus will receive the data from CPUs and based on that address, they go to the memory and input. And you can see the control bus. The control bus is again multidirectional, that is bidirectional, because I told you there is a control unit called as is there existing in the CPU that controls all the components that are connected with a computer. So that's why it needs to send signals to all the components, and also sometimes it needs to receive the signals from the input and output or also from the CPU. So if input wants to give any data to the CPU, first it sends a signal to the control bus that I want to give some input. And if output is expecting some data from the CPU, it requests the controller that I need some data like this. So that's why control unit is connected in bidirectional. So let us first discuss about a data bus. So a data bus, as we discussed, carries the data between the processor and other components. So collection of bytes through which data is transmitted from one part of a computer to another are there. So data bus is a multidimensional or bidirectional. Data bus can be highway on which data travels within a computer. Data, not control signals. Data, not address. Data is different, address is different, control signals are different. Data means actual input data or output data. This bus connects all the computer components to the CPU and main memory. As we have discussed, the length of data bus may be 32 bits, 64 bits, 128 bits, like that. Or even more lines also will be there. So the number of lines being referred to as the width of the data bus. So if you say, what is your data bus length? 128. What does it mean? 128 lines are there. So if somebody says 64 bus, 64 means 64 lines are there. So the number of bytes here specifies the length of the data bus. Okay, so definitely I told you it is a bidirectional unit. Okay, now the second one is address bus. So it carries memory addresses from the processor. It carries memory addresses from the processor to other components such as primary storage and input-output devices. So, see, if you want to receive the data from memory, from where you receive the data? From some location. How you identify that location? With the help of its address. From where you get the address? From the CPU. So CPU will give the address of a memory location. Or sometimes you may need to receive signals from the input device also. There are several input devices may be connected. I told you, mouse, keyboard, some pen drive. So from which type of input device you need to receive the data? Anyone. So who will decide it? Your CPU. But how you need to go to that place? With the help of this address bus. So CPU will give the address of the peripheral. Maybe keyboard will have its unique address, mouse will have its own address, or storage device memory will have its own address, like that. The address will be sent by the CPU. So with the help of these addresses, first it reaches to the location to transfer the data. After reaching the location to the current place, so then data will be copied onto the data bus. So clearly again, the width of the address bus determines the maximum possible memory capacity. For example, if the address bus length is only 2 bits, address bus length is only 2 bits, then zeros and ones are there, no. So with 2 lines, how many combinations we can generate? 0, 0, 0, 1, 1, 0, 1, 1. So with a 2-bit length of address bus, only 4 locations will be identified. If it is 3 bits, 2 power 3, 8 locations will be identified. 0, 0, 0, 0, 0, 1, 0, 1, 0, like 0, 1, 1, like that. If it is 4 bits, 16 locations will be identified, like that. If the number of bytes are being increased, the number of locations will be also more. So if n lines are there, 2 power n locations will be identified. Remember, if n lines are there, 2 power n memory locations will be identified. Again, this address bus length also in the form of 16, like that only. Okay. Now coming to the control bus. Just now, as we have discussed, control bus, it carries control signals from the processor to other components to do something. So because the data and address lines are shared by all components, there must be some means of controlling their use. See, input devices, output devices, memory unit, CPU, all these put together share the data bus and address bus. But who will control? When the data bus will be used by what device? When the address bus will be used by what device? So for providing the signals or for controlling all this, we need one more special bus called as a control bus. So the control bus is the one that is used to control the different signals that are transmitted by the data and address buses that are connected with various components of a computer. So the control lines regulates the activity on the bus. So these signals transmitted in the both command and timing information. It is also again a bidirectional. So here these are the three types of buses we have. So I will simply give you an example for this bus structure. For example, if I ask you to go to the library and to bring computer organization Morris Mano textbook, you just see here in this statement, I told you to go to library. Where I ask you to go? To the library. That is nothing but address. So I am giving the address to where? You are now using the address bus to reach the address, to reach the location. Fine. After you go to there, what you do? You need to bring the computer organization textbook of Morris Mano. So what is the data there? I ask you to bring Morris Mano textbook. That is the data. Now the data will be transferred to the data bus. So you are going to send. Fine. Address bus is okay. Data bus is okay. But where exists this control bus? See, if you want to pass from the place where you are onto the library. There is a path required. Fine. That path need to be controlled. And library sometimes may be closed. It should be opened by somebody else. Who is going to do is all is your control bus. The control bus is going to control all these intermediary problems or intermediary issues. This is the best example of using address bus, data bus and control bus. Now this control bus we have discussed. What are the basic operations or signals that are passed by the control bus? Memory read signal, memory write signal, IO read and IO write. So memory read means we need to read the location. Memory read. So from the memory, data may be read. Some data may be stored in the memory. So that will be read by the control bus. And we need to write something else. So for that also we need the memory location on which we need to write. So that is also controlled by the control bus. And input output devices. So from input devices we read the data. From output to output devices we write the data. So these two operations means basically control bus performs two basic operations, read and write. Two basic operations, read and write. And again storage unit and peripherals. Storage unit means memory. It may be primary memory or secondary memory. And peripherals means it may be input device or output device. So the basic four operations that are controlled by the control bus are the signals that are generated by the control bus are memory read, memory write, IO read and IO write. So okay. Now in the diagram, multiple bus structure diagram, we have discussed three types of buses are there. Okay. Now system bus we have discussed with three different. Local bus we have discussed data transferring between memory to the cache memory. In the system bus, three types of buses again discussed: data bus, address bus and control bus. The third one is expansion bus. See, I told you that data can be communicated not only between the components of a computer, between two different computers also, I told you, if they are connected with the LAN. So if two different computers are need to communicate, again there is a path must be existed between these two buses. So that path is with the help of the expansion bus. The name itself is telling you expansion. The bus is expanded. The bus is expanded to communicate the data or the control or the address not only within the system but also among the different number of systems. So an expansion bus interface buffers the data between the system bus and IO controller on the expansion bus. This arrangement allows the system to support a wide variety of IO devices and at the same time insulate memory to process traffic from IO traffic. Some of the devices connected to this expansion bus just now we have discussed. Network connections like your LAN, WAN, MAN, local area network, wide area network, metropolitan area network, etc. are connected together with the help of this expansion bus. And next device that is there connected is small computer system interface, SI, the small computer system interface. So itself is a type of bus again. And this SCSI purpose is it is used to support local disk drives and other peripherals. Means when LAN in the LAN or WAN, when two other computers are communicating with each other, what about the local drives and local peripherals? Who is going to take care about those? So for that purpose, we use this SCSI bus. So in the expansion bus, the purpose of SCSI bus, that is small computer system interface, which is again a bus called as, this controls or supports local disk drives and other peripherals. And the third one is a serial port. Why a serial port? I told you, communication will be between two parallel devices, communication between two single devices. So, and also between a parallel and single device. So, serial device, sorry, not single, serial device. So, here your CPU is a parallel device, whereas your printer is a serial device. or your scanner is a serial device. If sometimes if the CPU wants to send the signals or the data to printer or scanner, as it is a parallel one, sends n number of lines at a time, and printer and scanner are serial ones, receives only one bit at a time. To match this time gap, to match this speed, we need to connect a serial port. See, you can see in the backside of the CPU, there will be number of devices are there, components are there, serial ports, like parallel ports, like that. So serial ports will be connected with the circular shape connector, whereas parallel ports will be connected with your cabling, like cell phone cabling, etc., etc. So this is the expansion bus. So you can see the diagrammatic representation of the expansion bus looks like that. Okay, so in the expansion bus we have fax, modems, okay, serial ports, like that. Many things are there. Okay, so there is a high speed bus in between. You have seen CSE, P1 394, graphic card, video card, LAN card. All these cards are there in the CPU. So in the either front portion of the CPU or the back portion of the CPU, you can see these all graphic cards, video cards, LAN cards, etc., which are connected. So this high speed or maybe local bus or whatever, they are connected with the external bus with the help of a expansion bus interface. Okay, expansion bus interface. This is the diagrammatic representation how various devices are connected with the help of the expansion bus. Now coming to the next topic, bus design issues. See, just now I told you before, when we are going to design a bus, nothing but a group of wires, various factors you have to remember. And first one is bus width. What do you mean bus width? Just now length. Is it 2 lanes bus or 4 lanes bus or 16 lanes bus or what? So that's why we need to consider, depends upon the number of bits that we are going to transfer at a time. And next one is bus type. What is bus type? Is it dedicated or multiplexed? What do you mean dedicated or multiplex? Means one direction or multiple directions. So one direction, single, multiple means bidirectional. We have discussed in the single bus structure and the multiple bus structure also. Some components are connected in 2 ways and some components are connected only single way. That is either unidirectional or bidirectional. The next one, what are the various operations that we will perform? We have discussed read operation, write operation, block transfer, interrupts. Block transfer means a group of data will be transferred. Huge data will be transferred. That is one of the major basic operation of a bus. Now interrupt. What do you mean by interrupt? Means, say for example, when a CPU is given a signal to print n number of pages and it is going on. Say for example, the pages in the printer are over, then you will receive a signal or instruction on the screen that out of paper. So that is called as an interrupt. Sometimes cartridge may be over. So you may receive a instruction on the screen that cartridge is completed. Or somebody else may open the door while printing. So the printer door is open. Like that some interrupts may comes down. So these are all also will be transmitted between various components. Okay. And next one is bus timing. Bus timing means whether it is a synchronous bus or asynchronous bus. I told you synchronous bus, asynchronous bus. What do you mean with synchronous and asynchronous? Synchronous means if you are transmitting or transforming data between 2 devices of the same speed, means they are serial components, serial ports, then it is called as synchronous. Or else, if you are transforming data between a serial device and a parallel device and vice versa, then we need to have asynchronous bus. Asynchronous bus means it is transforming or receiving 16 lines, maybe 16 information, 16 bits, example, and passing to the any peripheral of serial input. Means one bit at a time can be passed. So 16 bits put together, received, and passing only one bit at a time. Definitely 16 bits where we need to store. So if by the time of transferring the 16 bits, again the CPU may sense some more 16 bits, or the data is going to overlap. If the data is going to overlap, the communication what the device is getting may be wrong. To avoid all these things only we are using buffers. Buffers are temporary storage devices. Buffers are temporary storage devices that are used to store the data received by the CPU, because it is a parallel device, and one by one will be transferred to the serial port devices. In that way, this asynchronous problem will be rectified. Okay. Now, these are the various design issues we need to cover. Of course, there is one more design issue also is there, arbitration. Arbitration means centralized or distributed. So, means this bus is distributed among different types of networks like local area network, wide area network. So, if you want to distribute between the local area networks, you know the definition of a LAN itself is under single roof. Okay, that's why you can connect all the systems with a group of wires. But if these computers are wide area or metropolitan area but still wants to communicate, how you communicate? Is it possible to connect with the help of wires? The two computers that are under WAN or MAN? Maybe, but it is a lot of costly process and difficult to connect also using wires. That's why we need wireless communication. So that data also will be transferred between two different computers that are located in different places with the help of wireless communication. So when you are going to design a bus, whether it is wired communication or wireless communication, also you need to consider. So bus width, bus type, bus operations, bus timing, also bus arbitration, whether it is centralized or distributed. So these are all the various issues you need to keep in mind while you are going to design the typical bus. Now, thank you one and all for listening this bus lecture patiently. Still, if you have any queries, as we have discussed already, my phone number and mail ID is given there. You can communicate with me by using any of these media for clarifying your doubts. And dear students, in this week we'll have some interaction session to directly communicate with all of you. So I will pass the information to download a software. It may be either Zoom or Google Meet or whatever it is. So maybe this weekend we'll have a session of discussing my way of teaching or some any problems that you are facing. Still, if you have any doubts, I told you, but I don't know whether you got doubts from the first two sessions or not. I have not received any messages through WhatsApp or mails. There are maybe two cases where you don't have doubts. One is if you understand everything fully, or if you don't understand anything. So, either the cases. The first case, it's very happy. In the second case, if it is too bad. Try to understand something. If you have any doubts, you can ask me, and you can feel free to ask me. So, thank you one and all for listening the third topic, that is bus sector of your part 1 of unit 1. I told you, unit 1 is divided into 3 parts: basic computer organization or basic computer structure, part 1. In that, basics, generation of computers, that is historical perspective. Third one is bus structure. These 3 topics of the first part are completed. Now next class we will move on to the second part, that is data types. Thank you one and all.